Hey folks, in this video we're going to be talking about how to do math with significant digits. Oh my gosh, what are our objectives? Well, they're for you to be able to perform addition and subtraction with significant digits, and also to be able to perform multiplication and division with significant digits. So let's start with that first one, addition and subtraction. Well, whenever you're doing addition and subtraction with significant digits, you want to determine which number runs out of the significant digits first as you move to smaller and smaller places. So let's look at an actual example because I have a hard time articulating this one and a better time giving you an example. But whoever runs out of places first, that's going to determine how many digits you're allowed to put in your answer, or rather which place you're allowed to write digits to. So let's compare these three cats, okay? So our first dude, 1.005, has significant digits all the way out to that thousandth place, all the way down there. Wow! 20.5 has significant digits to the 10th place. That's the smallest place that it has significant digits. And 405 has its smallest significant digit in the ones place. So if we looked at these and we added them together, well, we could say, okay, 405 has significant digits. It runs out of significant digits first as we move to smaller places, or its last significant digit is in the largest place. It's kind of hard to articulate that one. It doesn't come out very pretty. But what we can do is just sort of look at these and see, all right, that's how I process it. Who runs out of significant digits first? This guy runs out in the ones place. So if I add these together, my answer will have to end in the same place for the ones place. So when I add up all these bad boys, I get this number, but I have to round to the ones place if I'm going to be right with significant digits. And so I find it's helpful to line up addition and subtraction problems vertically so you can see which place you want to chop things off at. Let's look at that in some example problems. So if I add these puppies together, what I'm going to do is see where do they run out of significant digits. Well, this dude stops at the hundreds place. This dude goes all the way to the ones, but I ran out in the hundreds. And this one goes all the way to the tenths, but this dude ran out in the hundreds place. That's the last significant digit in this measurement. So our answer can only have significant digits in the, sorry, that's the hundreds place. My mouth failed. In the hundreds place and forward. So when we add these up, we're going to get this fancy pants number, but we have to round that into the hundreds place. So I'm going to round all this up and make this 8 a 9. Let's look at another example. Why don't you pause the video and try this one on your own? Okay, sweet. You paused it and you tried it out. Well, as we look at these, this dude goes all the way back to the 10,000th place. I'm sorry, that's the 100,000th place. That's pretty far back. This dude goes back to the thousandths, while this dude cuts off at the hundredths. This one runs out of significant digits first as we move backwards into smaller places. So my answer, I'm going to have to cut off at that hundreds place. I'm going to round this up to 4.40 because I still want to have a significant digit there. Even though I'm rounding up, I'm still going to want all my significant digits that I can get. And why don't you pause the video and try this subtraction problem? Neat, you pause the video, let's talk about it together. So first I can just do the maths, and now I can look at it again and say, all right, well, you go out to the hundreds place, you go out to the thousandths place, you go out to the tenths. Tenths runs out first, or it's the largest of those places that I just mentioned. So we're going to cut our answer off at the tenths. Nifty, and that's how we do addition and subtraction with significant figures. Cool. Yeah, wow. So multiplication and division is much easier to explain with words. So when you're doing multiplication and division, look at the numbers you're multiplying, dividing, and figure out which one has the fewest significant digits. Now, your answer can only have that many significant digits. So let's look at some example stuff. Let's compare these three numbers. So my first number, 33.5, has 3 significant digits. My second number has is 1.2, and it has 2 significant digits. And my last number is 6.700, and those zeros are significant because there's a decimal point. So that dude has 4 significant digits. But what if I were to multiply all these dudes together, this 1.2, who is the fewest significant digits, will tell me how many significant digits are in the answer. So I multiply them together. It has to have 2 significant digits. So I'm going to round this fancy pants answer up to 270. Cool buns. Well, let's look at some actual example problems. Oh, but I should mention, and I'm going to have to make my face disappear, I should mention that if multiplication and division and addition and subtraction are present in an equation, you have to follow the order of operations and the rules significant digits rules for each one. So when there's multiplication, you need to resolve that multiplication first and figure out how many significant digits should be in your answer before you can do the addition or subtraction that you need to do. Cool. So practice time. Let's go through this one together. So I'm going to look at these dudes and I'm going to figure out who has the fewest significant digits. Well, I can do my box and dot. I'll box up my non-zero digits, and since there's a decimal point, my zeros that trail as well. I'll do the same here. Oh, that dude's got 3 significant digits because there's 3 digits in boxes. And this dude here, I box up my non-zero digits and we're done with that. That's all I have to do. There's a decimal point, but there's no trailing zeros over here, so it's got 5 significant digits. And this dude, I box up my non-zero, that's the 6, but there's a decimal point, so I'm going to box everything to the right of my first box. There's 4 digits in boxes, so 4 significant digits. Well, that doesn't matter because this dude has 3, so I'll multiply them all together, and I'll round my answer so that I have 3 significant digits. Hot sauce! Why don't you try this bad boy? Pause the video and give it a shot. Cool. Well, we're going to look at these, and I'm going to say this dude has 4 significant digits. These zeros count because we got a decimal. This dude's going to have 4 significant digits. Box up those, and this 0 counts because we got a decimal. And this dude's got a measly 2 significant digits. Box up my 1 and 2, but these dudes just don't count because I got no decimal point. So my answer has to have 2 significant digits. So I'm going to multiply these together, and we actually run into a little bit of a problem here that is actually a really nice opportunity. Because if I write this as 300, that's only going to have 1 significant digit. If I write this as 300 and I put in a decimal point, well, now it has 3 significant digits. I would box up these zeros. So the only way to properly express this is using scientific notation. I can write 3.0 times 10 to the second, and whenever I write in scientific notation, all the numbers in my coefficient are going to be significant. So that's really the only way to properly express this answer, which is 300, but it has to have 2 significant digits. Nifty. Let's look at one more problem. Pause the video and give this dude a shot. Okay, sick. Let's go through it together. So first, I'm going to handle this maths of multiplication because multiplication comes first in order of operations. And so I'll multiply those dudes together. This dude has 4 significant digits, and this dude has 3, so my answer should have 3 significant digits down there. And then when I add these together, I'm going to line them up because I like to line things up when I add them together. And I can see right now that this dude runs out of significant digits first. So I want to have my answer ending in the 10th place. So I'll record this as 16.9, and shazam, we're done with that. Cool. So I hope you understand how to do math with significant digits, and I hope you have a great rest of your life. Ta-ta.